All right, hello everybody. Hope everyone's having a good day. Today we are going to work on our 8.8 notes. Our goal today is to use logs to solve exponential growth and decay problems. All right, so as I promised, I told you guys that we would be using this formula, and often it is referred to as the PERT formula, okay? The amount is equal to PE to the power of R times T, or this can be written with a K also. And I told you that that K also represents the rate. So E is just your general variable, just to talk about this a little bit. E is that variable that we see often that represents this number. Your calculator memorizes that number, so no need to memorize it. The T is going to represent your time. Remember that the unit for time has to match whatever that unit is in the rate, so just be careful of that. If your R value is greater than 1, it's going to be growth, and if it's smaller than 1, it's going to be decay. This is a little bit different than the exponential growth and decay that we saw earlier, because we use the base as your growth factor, and we talked about it being between 0 and 1 or above 1. This is not that same growth factor, okay? This is in an exponent, so it is either negative or positive in this case. Your P is your principal or your initial amount, okay? So we're actually going to use this continuous growth and decay. As I mentioned in your 8.7 notes, when does this come in handy? When we're dealing with accounts like with money, what happens is at the end of every month, the bank says, okay, we're going to pay you interest. At the end of the month, here is $5 of interest. Here is $6.27 of interest. Here's a specific amount of money of interest at the end of the month. However, when we're dealing with like bacteria growing, or in chemistry, we're going to work on like carbon decay and things like that, half-life, double life of different organisms. What happens is no one says at the end of this month, here you go, your carbon has now doubled, or anything like that. So what happens is it's continuous growth. It doesn't happen at the end of the month. It is happening continuously over time. And that's when we're going to use this equation. So the half-life of carbon-14 is 5,730 years. Determine the rate R and the equation representing decay. All right, so just like we did when we were doing compound interest, I was showing you how I like to write out all of the variables. So A, P, E, R, and T. All right, and so what you're going to do is you want to fill in all of these right away. Now, E is always given to you. That's the 2.718 dot, which is on your calculator. So no need to memorize that. So that one is always filled in. This will kind of just help you, if you write it all out, to figure out, okay, what is it you're looking for? Because if you know what it is that you're looking for, and this one says to determine the rate R, okay, this is the big question mark right now, is your rate. That means everything else is given to you in this description. You have to just figure out where it is and what it is you know. So what is the initial amount? It says the half-life of carbon-14. This 14 number means nothing, okay? It's the type of, I think it's considered the isotope of carbon. That would be a question for Miss Olshevy. But anyways, that carbon-14, it's just the type of element that we're talking about. It has nothing to do with one of these variables. So the half-life of carbon is 5,730 years. Determine the rate. And people get confused because they're like, okay, I can see that the time has to be 5730. This is years, right? Okay, cool. We got that part. But the problem is we don't have the end amount or the initial amount when you read this. However, you do. You can make it up because the half-life says that if you want, you can choose. If you want your initial amount to be 10, then when it reaches its half-life, how much is left? 5, okay? Let's say you wanted your initial amount, your principal amount, to be 100. At your half-life, how much is left? 50, okay? So it doesn't matter what you choose as your initial and your end amount. You're just using that half-life idea, okay? So let's actually solve this. I'll leave it as the 50 and 100. And we're going to fill in everything that we know here. So we have 50 is equal to 100. E we know, but we're not going to write it in because our calculator is going to know it. We don't know what R is, and our time is 57:30. All right. So first thing that we're going to do is we have to get this by itself because this is the variable that we're solving for, that R. All right. So in order to do that, if this said 50 equals 100x, you would divide by 100. So you're going to divide both sides by 100. Okay. 50 divided by 100, that's going to reduce to 1/2. If you want to write it as 0.5, I'm totally fine with that. That's actually what I'm going to write it as. Okay. And now I want you to notice that this equation right here would look the exact same if we would have had two different values here. Let's say you would have chose 1 and 0.5 originally. If your initial amount was 1 and your end life was 0.5, then you would have automatically led you right to here. Okay. If you would have had, find a different color, initially 2 and your end was 1, then this would have been, your amount would have been 1, here would have been 2, you would have divided by 2, you'd still be here, okay? You would have gotten here no matter what. So I just wanted to point that out to you because it does not matter what you choose as your initial and your end amount, as long as your end amount is half of whatever your initial was, okay? Then you're going to get here. All right, so then let's talk about how can we solve this? Now, I would go ahead, since it's, within an exponential equation, I would convert it because you guys know I love to convert. So you're dealing with the natural log base e. So this is natural log of the answer is 0.5 is equal to R times 5730. Okay. All I did to go from one to the other was convert. Okay. Maybe you're used to seeing this this equation backwards. Write it backwards if that helps you. I don't care. Write the left over here and write the right on the left and the left on the right. It does not matter. All right, well, R is almost by itself at this point. The only thing left to do is to divide by 5730. And you're left with R. And so what you get is that R is approximately, and this is where it would have been great if we were in class right now because I like to show all of this. You have most calculators at this point they're going to give you scientific notation. So it's going to tell you it's negative 1.2097 times 10 to the negative 4th power. Okay, what that tells you is that this is the same thing as negative 0.000122097. Okay, it's as if you were to move that decimal place 4 places. Okay. Now, what I like to show in class then is how you can store this number on your calculator. If you have a graphing calculator, there's a button and it looks like this. It says store, S-T-O, and if you click on that and then use the alpha button, like make it alpha R, so that it stores it as your R value, it's going to store all those additional decimal places that your calculator knows from this exact expression that you typed in. So that'll just help in the long run with the whole rounding issue, because what happens is when you deal with super small or super large numbers and you type them in, it ends up showing that they're pretty far off. Okay. And what we just did was we were able to use this to write an equation. So now what our equation is the amount is equal to your principal amount times e to the power of negative this is your r value, and it's 3 zeros, 1, 2. We'll leave it like that for right now, times t. So that equation will actually tell you how much carbon you'll have left after a certain number of years. So we can use that for part B. Okay. Part B, again, you're going to want to know what A, P, E, R, and T are. I'm just going to put an X there. You guys know what E is. So if you have 20 milligrams of carbon, so that sounds like that's your principal amount is 20 milligrams. How much carbon is remaining? Yep. It wants you to find the remaining after 1,200 years. Okay. Now what about R? But wait a minute. Carbon-14 is always going to have the same R value. So the R that you found up here is actually the R from down here. So if you use that store feature I was mentioning on your calculator, on this scientific, the blue ones and the purple ones that I have in class, there is a way for you to store on there as well. I can probably find a video and I'll also post that. But if you use that store feature, it makes it a lot easier. Otherwise, I would just type it to at least 4 decimal places here. So 0.0001209 7 would probably be best. So anyways, now that we know that our rate hasn't changed, it's the 0.0001209. Oh man, I'm having that problem again where it's right there where I go on to the next page. So, anyways, the rate is the same as up there. I'm just going to not even write it. Okay. So you guys know that rate is this one up here. Anyway, so now we're going to go ahead and we're going to fill in our equation. So the amount is equal to principal amount we have. All right, so our principal amount is 20 milligrams. 20 times e to the power of our r value is what we know, so the negative 0.0001209.7. Our time is 1,200. Okay. Make sure that when you're typing this in, this is all in parentheses. That's a big issue that I often see every single year with my students. So if you do this correctly, this can all be typed in all at one time. And as I mentioned, you can use the store feature on your calculator. So use, store that in your calculator so you don't have to type out that whole long, huge number. Actually, it's a really small number, but anyways, you guys get my point. So our amount is actually going to be 17.3 milligrams remaining once you type that in. So make sure that that's what you're getting when you're typing it in, and if you are, you're doing it right. Okay. All right, 2 more examples in this, or actually there's another section, another part to this. Let's see. So part C says the bones are a prehistoric animal. Must be the bones of a prehistoric animal contains 2% of the carbon-14 that it once did. How long ago did the animal live? Okay, so again, let's write out what all of our variables are. Again, E we know. R is going to be stored on our calculator. Okay. This is from A. part A in our from our notes before. So it's like the negative 0.00012 number. It keeps going. Time is how long ago did it live? So that's the big question mark here, time. That means in this question, they have told you the amount at the end and at the beginning. So this 2%, the fact that it contains 2% of the original, is telling you the amount at the end and the amount at the original. So if you had 100, whatever, it could be milligrams, whatever unit, it does not matter. Whatever you started with, if you started with 100, if it only contains 2% in the end, it has 2 of 100, right? Percent means out of 100. So that percentage gives you both of those. If you wanted to, you could alternately use the numbers 1 here, then you would use 0.02 here. Okay, it doesn't matter. It does not matter. All right, so here's our equation. We found that in A, and we used it in B, and now we're going to use it again in C. Now we can fill in everything that we already know. So if I want to use the 2 and the 100, I can do that. E to the power of negative 0.00012. Oh, my point didn't show up. The time, I don't know my time. I can even make that red so that I can see that that's what I'm trying to get by itself. But in order to get that by itself, I have to get this whole thing by itself first. Okay, so since I'm trying to get that by itself, I can divide both sides by 100. And look at that. This is going to be 2 divided by 100 is 0.02. There's that t that we're looking for. All right, now notice if you would have used the 1 and 0.02, it just showed up. Here's your 1, here's the 0.02. So if you start with your principal amount as 1, you actually just cut off a step, or 2 steps, I guess, if you don't write this, which doesn't matter. Okay, so the next thing you're going to do is I would go ahead and convert. Because that's the easiest way to solve these. So we're going to have log base E of 0.02 equals the exponent, which is negative 0.00012t. All right. This log base E is just ln. Remember that. So here I'll change it. Okay. This you can... this right here, you can evaluate in your calculator, okay? That means this is a number equals a number t. You guys know how to solve this. This is just linear. So from here, you would divide by that rate, which should be in your calculator stored, okay? That goes away. You're going to have t by itself there. And so then once you find t is approximately, you should get 32,339.3 years. Okay. And then that would be your answer. I apologize. Lulu was trying to get my attention there. So that's what we should get for our time. And then you can see that, you know, from A, you can find all the R value and then plug it back in to answer multiple different kinds of questions that I want you to find. Okay. This next example is just a quick example. We originally figured out, you know, we did a problem with half-life, but I also wanted you to see a problem with double life. So it says find the value of R if the double life of a bacteria that grows exponentially is 15 days. Remember when you're doing these that it is important to pay attention to the units of time, okay? So just be careful of that. So the amount, if it doubles, your final amount would be 2 and your initial amount would be 1, okay? The time it gave you was 15 days. And E we already know, and you're trying to find the R value. Remember, it can sometimes be referenced as the R value or the K value. So if you see the K value, it's the same thing. All right, so let's go. So we have A equals PE to the power of R times T. Your amount is 2. The initial amount is 1. You don't have to even write 1 in there because it's just 1 times E. If you want to write it, that's totally fine. I'm going to write it just in case you wanted to use different numbers for the initial and the end. E to the power of R, we don't know, so I'm going to write that in red because that's what we're looking for. And our time is 15 days. All right, so first thing you're going to do is you divide both sides by 1 in order to get rid of that, whatever number that is there up front. In this case, it didn't do anything. All right, go ahead and convert because it's in the exponent, so you can't get to it. You're going to have log base E of 2 is equal to R times 15. Okay. Ln of E is natural log, so let's go ahead and we're going to change that to read the natural log. Okay, natural log of 2 is equal to 15. Then we can divide both sides by 15. So in order to find R, we have the natural log of 2 over 15. And you're going to find that R is approximately 0.0462. So if they wanted you to write an equation, sometimes they'll say write a exponential equation, blah, blah, blah. Then your equation would be the amount is equal to the initial amount times E to the power of your rate here was 0.0462 times T. Okay. Notice that this growth rate it's a rate, or I'm sorry, it's a growth because it is a positive R value. So the positive R value tells you that it is growth. So that's kind of your hint that you've done it right, because if it's doubling, then you know that it's growth, versus if it's decaying, then it should be negative. So hopefully that makes sense. And if you guys have any questions, let me know.